This video is a walkthrough of the Credit Commons demo site, and it should save you getting lost on the site yourself, or if you don't want to experiment with it by yourself but just see what it's about, this is the video to watch. So first of all, I want to say that the Credit Commons is an accounting protocol, and what you're looking at is a reference implementation of that protocol, similar to the way in which the release of the Bitcoin reference was a demonstration of the Bitcoin protocol. So this video is just to show you what the reference implementation does, and you'll get a feel for what the Credit Commons does as a result. First of all, I want to show you the tree structure. The Credit Commons is a tree structure of independent nodes, and each node contains a mutual credit ledger. So on the top level of the tree, where we've got these subgroups, that's like the end users, an individual community currency project or a business barter system. And then as we get towards the root of the tree or the trunk, so those groups are able to communicate with each other. So if subgroup 1 wants to trade with subgroup 2, it will do so through group 1, and if subgroup 1 wants to trade with subgroup 3, it would do so through group 1, supergroup, and group 2. The interface you're looking at the moment is the developer's interface. It's important to understand that because the Credit Commons protocol is a web service, it doesn't have a user interface of its own. So this user interface was used to make the process of development easy, and it's available to people who want to continue developing it. There's a special error handling within this reference implementation. It's part of the API as well, and the idea is that because requests are being relayed from node to node to node, and each node is its own web server running its own PHP with its own database, if something happens on a remote node down the chain, or downstream as we say, then the error needs to be relayed all the way back to the user interface so you can see what's going on. Otherwise you end up digging around in error logs. The demo site that you're looking at is renewed every hour, so hopefully there won't be too much traffic. If you come to it, you'll see it clean like this with no transactions on it. So I'm going to connect to subgroup 1, that's this one, and I'm going to do so as Bob because Alice is the admin. I want to show you around this screen a little bit. First of all, understand that the client can only connect to one node at a time, and then you can choose a user to connect to that node as. There isn't any authentication as such within the Credit Commons if you want to connect as a user, but when the nodes connect to each other, they connect as remote nodes, and there is a kind of handshaking process because you have to make sure that the connection is integral between the two nodes, which is to say that they're keeping the same ledger records, so they have the same balance with respect to each other. So in this reference implementation, you can simply choose a user to log in as. But since the Credit Commons is a web service, authentication would normally be handled elsewhere by the main platform. So the idea is you would have some kind of social network, and you would use the Credit Commons to do the accounting part of that social network. And so users are already logged into the social network, and then the social network can connect to the Credit Commons using an internal channel. It doesn't have to be specifically authenticated. It just has to state which user it wants to be. So we can see the microservices here. At the moment there are 4 microservices. The ledger is the main one, and in fact it's the only really public facing one, unless you want to configure the services using a user interface, which you would have to build yourself. So the other 3 microservices are in service of the ledger. They're called by the ledger and not available to the public. And then for each microservice you can see that there are methods. And so the idea is, behind this user interface, it just helps you generate a valid request, and then it will show you the response. At the bottom of the screen you can see the OpenAPI specifications. You can click and see that on GitLab, but you can also have a look at any previous requests that this system has made. So it's logging all the requests and all the responses. So you can see the raw JSON objects and REST requests and responses if you want. Okay, so let's get on and make a transaction. We already know that in subgroup 1 we've got 2 users who are called Alice and Bob, and so we can make a transaction between them of 10 with a description of blah blah. You just have to be careful that you're using the right workflow. Here's the workflow options, and in this case the author credits another account, so Bob will credit Alice, and that means Bob is the payer and Alice is the payee, so that should work. And so now the transaction has been validated, it's come back, and I'm asked to confirm it before it gets written to the ledger. Down here we can see the raw object which came back, including the action which I'm permitted to do, and we can also have a look under the hood here, and we can see a kind of step-by-step process about what happened inside the ledger. That's a lot more interesting when we are doing cross-ledger transactions or transversal transactions. So I'm going to agree with that transaction, and now it appears in this section state change, where it enters the workflow. Well, at the moment all I can do as Bob is erase this transaction. But if I go and log in as Alice, the transaction appears at the top because it requires her attention, and she's invited to sign it. So if Alice signs the transaction, then it moves into a completed state, and that means Bob and Alice's balances are both changed. Let's see if we can look at the balances. Here's an account summary, and we can look at Alice, and we can see that her balance is 10. Also, it shows you the pending balance, which is also 10, meaning that it's the same as the actual balance. But if you have a transaction in a pending state, like before Alice signed it, then it wouldn't show as the actual balance. And then you have some other trading statistics there as you need them. So just before we go on, I want to show that you can see the effects of this transaction on Alice and Bob's balances. So Alice is plus 10 and Bob is minus 10. And of course, because it's mutual credit, plus 10 minus 10 equals 0. And that's how we know that the ledger is integral. Okay, so we're going to go on and do a transaction from subgroup 2 to subgroup 4. And this will go right across the tree. So let's make sure it's the right way around. Alice, the author, credits, that means she has to be the payer. And we're going to address Bob in subgroup 4. So that means we write the full path, group 2, subgroup 4, Bob. And we'll do the same transaction. So there it is. The transactions come back for Alice to confirm. And then we'll go and confirm it as Bob. And then we could see the transaction has gone right the way through the tree. So there's Alice, the black account, and all of these grey accounts mean that they are the balances that are happening on other ledgers. And so there's Bob, who's gone up. Notice that Bob's balance is 2.5, not 10, and that's because there are exchange rates operating between all of these ledgers. So it's all been converted automatically. So Bob's 2.5 balance is in fact an equivalent amount of credit, as if credit was some kind of universal stuff. It's an equivalent quantity to Alice's minus 10, but it's just measured in a different unit. So let's go back and have a look at some of the other microservices and methods. Here in the Ledger microservices, you can also filter transactions by any of these usual fields. You can view the accounts both locally but also in the tree. So there's the local accounts. We can see a bit more detail on those accounts. And we can also view them as a tree. So there you can see Alice and Bob and the Rootwoods account, which is called Group 1. And then on the Group 1 node, it's got its own Alice and Bob, and it connects to the supergroup. And then it's referring to subgroup 1 and subgroup 2. And then the supergroup refers to its branchwood nodes Group 1 and Group 2, and it has its own Alice and Bob, and it also has an account for collecting fees. Here you could do much the same. You can get the account details for Alice or Bob, also people on other nodes. Note that you can only look down the tree towards the root. You can't look inside other nodes because they're private. It's none of your business. So you can only see the accounts of groups of which you are a member. We can also look at the balance history of any account, meaning the moments when the transaction occurred and what the balance became, and change the config for the ledger service. Looking at the policy service, and of course you might not want to implement this as it is, you might want to build your own, because the policy service contains the list of valid accounts and also the balance limits for each account. So here we can look at Alice's account. We could see the minimum and maximum balance there. But otherwise, there's very little data kept about any of the individual users. So it's not intended to be a full social networking platform, but just an accounting service for a platform. Here's where you would create a new account. You could filter, you could get a list of all the active accounts on this node. Override policy would enable you to change the defaults for each account, and then there's a bit of config. Well, you set the defaults for each account there. So the business logic service is where you pass it to the transaction, and it may decide to add or not to add different fees. So I've supplied a bit of transaction data there just to test with. And it says that on this node there's no additional entries, so there's no fees charged on this node. And there's the config that says that there's no fees charged on this node. Finally, the workflow service. We've got two workflows available. Workflows will be inherited from the rootwards nodes, and that ensures that when you do a transaction with somebody anywhere across the tree, you will always have a transaction workflow in common. So it's critical to share a transaction workflow, because both nodes have to agree who can do what to the transaction in order for them to stay integral. So here's what that looks like. This is basically a config file that states who can do what. So here's all the workflow states: init, validated, pending, completed. Here's the states you can move to from that state. So for example, from the validated state you can only move to the pending state, and from the pending state you can move to completed or erased. And then it says which of the relatives of the current transaction can actually do that. So for the credit workflow, only the payee can move the transaction from pending to completed. So that's the end of the walkthrough. Feel free to install it using the links below and experiment away. And of course, I'll be very happy to receive suggestions of improvements. Thanks for your time and attention.